In our next segment, let's discuss primitive data types. Kind of strange term to use. Another term to use is fundamental data types or basic data types. It has the same meaning, right? In 1 second, I'll explain. But first, examples. Double price equals 1.55. Boolean is okay to proceed equals true. Integer count equals 0. And perhaps we already have seen examples of other data types such as string, but you see that some of the data types, you can see that the double data types creates a floating point variable, which means that we can use fractional numbers with decimal floating point and fractional part. Right? Then we have Boolean data types, and of course we have integers. The one to demonstrate also would be a character. Character ch equals a. Right? Examples of these. These three data types, double, Boolean, integer, and character, which are very popular when we write the code, are called primitive or fundamental or basic for one reason. They're recognized by hardware directly. So, which means, the meaning of it is that CPU instructions which will deal with this code to initialize this, to create and initialize these variables, will not need to break these statements to separate instructions. It's essentially is just like, there's usually when there's arithmetic operation or an assignment or, moving values from one place to another, there's typically a CPU instruction that understands directly the double type of variable, the Boolean type of variable, the integer and the character type of variables. That's why they're all built-in variables. Right? Built-in, by the way, built-in is yet another built-in or primitive or fundamental or basic data types, right? So these are all synonymous to describe the same thing. Of course, C and C++ give special recognition to fundamental data types so that there are keywords such as double, bool, int, and char built into the programming language. And the meaning of the keyword is that this thing, right, is taken away from your vocabulary. You cannot create variables with this name, or you cannot define your own data types with this name because they're already made part of the programming language. Okay, so to demonstrate, if I wanted to say int double equals 1, 2, 3, this would be an error. If I try build it, it'll tell me that int followed by double is illegal. So essentially it says you cannot name your variable a double, right? So because it's already a keyword in the programming language, so I need to use a proper name. Okay, I'll just remove this for now. And of course, double stands for double precision floating point. It's like 8-byte size, very precise value, has a very big range of numbers that you can specify and very high level of precision in there. And it's intended for typical, scientific, financial, other types of computations. Integers are good for counting, you know, specifying integer values like 1, 2, 3, 4, 5, and also using negative values as well. By the way, if you read the tutorials that I provided at the top of our week highlight, you learn more about these primitive data types. So I'm not going to stay on this topic for very long. What I would like to say that I'm curious what would happen if I attempted something like this. Instead of setting my counter equals 0, what if I tried to convert a double price, which was given this value, to an integer? What would have happened? So let's just move this character up to the top, and let's use our friend cout to display, for debugging purposes, to just display count equals, and we will show what it contains. Over here. So let's give it a try, just to see what's going on. First of all, let's build this program. Now, one interesting thing to observe is that the compiler gives me the warning right here. And if you want to know where this error is or what is the warning applies to, you just simply double click on the error message, and you see this helpful marker comes up, and it says part of this assignment, what I think is this, and I just copied and pasted it here. So let's just kind of like try to read this in its full description. It says we're trying to initialize integer counter apparently with this value. You see that creation of the variable permits instant initialization, instant provision of the initial value to the new variable count, and it says warning such and such. By the way, these warning codes are very helpful because if you don't understand what is the meaning of the warning or the meaning of the error, you can Google search or use your favorite search engine, and you're very likely to find many more answers and detailed explanation what is the warning or error, in what circumstances, like examples where it may be happening, and that is tremendous help in understanding what is the problem with my own code, right? So something wrong with initialization, conversion from double to int, possible loss of data. Okay, so if we speak about the double, right, and if we have these bytes, right, in memory, so the size of the double is looks like this: 1, 2, 3, 4, 5, 6, 7, 8. This is how much space in memory a double variable requires to store its value. It's quite large, so that's why it's very precise and has a significant range in its values, right? On the other hand, an integer variable is only 4 bytes, 32-bit size in memory. So I'll just write this comment right here, right? So and although it gives me the warning, compiler says that okay, because this is a numeric value, and this is also a numeric value, I will allow this code to compile. But what it does, instead of rounding the fractional number to perhaps its rounded value conventionally would be the value of 2, it simply removes the fractional portion and simply assigns 1 to count. And that's why it says, look, when we're trying to convert double to int, it's very possible to have some loss of data, it's your choice whether that loss of data is okay with you, or you're the programmer, you should know what you're doing, and I'm giving you the warning, so you need to pay attention to what I say. All right, so let's just quickly run this code and to observe what it's doing. So first I build it, right? So again, it gives me the warning, then I run it, and you can see that yes, indeed, it prints count equals 1 as a result of execution. So when I execute this code, the output here, right? So the output that I'm getting is this: count equals 1. Okay, so this is just a highlight, and there is a very simple trick to do this, which exists in a lot of code. Now there are rounding functions available in standard library, but still one possibility to provide correct rounding is to do something like this. Sorry, say plus 0.5. So this is a way to make sure that when you're converting a floating point value to an integer, that the rounding, correct rounding according to conventional rounding rules, is taking place. Rounding is very specific and very sensitive topic in a lot of in a lot of areas like financial computations. Rounding can have different styles. Is a significant topic, but this is a very basic type of rounding, and this time you see the initial value was 1.55, and now I'm rounding it with addition of 0.5. I'm building it again. It still gives me the warning because I'm still converting from double values to an integer, but when I run it, you see that now it's more of an expected conventional outcome, so this becomes a 2. So what's happening here? 1.55 plus 0.5 is 2.05. When 2.05 as a result of this expression is converted to an integer, 0.05 is thrown away and remaining 2 is assigned to a count. Right? So let's experiment with other possibilities. If I make it 1.0, right? So if I remove entirely fractional part of it, and so this time I convert price, which is 1.0, to an integer, and so this time price is 1 plus 0.5 is 1.5, but we know that this initialization simply throws away the fractional portion, so it becomes a 1. So it still works correctly. So 1.0 is a result of using this approach to convert price to double to an integer. It becomes correct outcome 1.0, right? Or if I make it 1.99, right? So if I do something like this, right? So this is very close to 2, right? Almost 2. So of course I want this to be converted to 2 when I convert it to an integer. So what happens here? 1.99 plus 0.5, right? So this would result in 2.49, and of course 2 will be taken and 0.49 is thrown away. So it still works correctly. So just something I thought you should know, because when you look at the existing code, there's lots of code where conversion from a double to an integer takes place, and this is something to expect to see in millions of lines of code that exist out there.